This is a lecture on 9-3, testing the difference between two means-dependent sample. Now the difference between 9-2 and 9-3 is in 9-2 in the previous section, what we were dealing with is two independent samples. So if you were going to enter this in your calculator, you would have an L1 and an L2. Now, when you're talking about dependent samples, what we're analyzing is the change per subject and that depend on one another. For example, we're talking about the same car before and after. We're talking about the same person before and after. We're talking about the same bank now and then 3 years from now. So what we're dealing with is we have a test statistic that is analyzing something called a D, and it's the difference. The D can be found by taking an x1 minus an x2. So the test statistic is a T that takes an average of the differences, subtracts the hypothesized mean for the difference, the standard deviation of the difference, and then the square root of n. So the formula itself looks just like a one sample t-test because that's what we're going to be doing. The d bar is the average mean of the differences, and S sub d is the standard deviation of the differences. Now, because we will create an L1 that will reflect that D, so what we're doing is we're running a one sample t-test. It's a simple t-test. Chances are on data. So why don't we take a look at the first example that is in the book. It is 9-7 example. A dietitian wishes to see if a person's cholesterol level will change if the diet is supplemented by the certain mineral. 6 randomly selected subjects were presented, and then they took a mineral supplement for 6 weeks period. The results are shown in the table. Can it be concluded that the cholesterol level has been changed at alpha at point 1? Assume the variance is approximately normally distributed. Now, this approximately normally distributed allows us to even talk about a sample of n is equal to 6. Okay, if we don't have that, we can't discuss any findings on n is equal to 6. What else we have is, well, pretty much nothing else is given to us in the problem itself. The only other thing that I would want to highlight is the fact that it is a two-tailed test. Let me go back to my notes for a second. The null and alternative hypotheses for this particular section reflect on the fact that I'm talking about the mean differences and it should be 0. So mu sub d is equal to a 0 will be your null hypothesis for every single problem in 9-3. The alternative hypothesis, we will still label it as a mu sub d because it is not the mean of either one of the samples. It's the mean, or in this case, hypothesized mean of the differences. And it's going to be either not equal to, less than, or greater than or less than that same 0. So having mu is equal to a 0 means that there is no difference between before and after, and the alternative hypothesis says there is a difference between before and after. So the word changed suggested that we are talking about a two-tailed test. So I'll set up my null hypothesis as a mu sub 0 is equal to a 0 and mu sub mu sub d is equal to a 0 and mu sub d is not equal to a 0. So this is where we start. We are looking at a t-test. So what I'm running is a t-test, two-tailed, with a degree of freedom of n minus 1, which is 5. Before I start, I need to create this differences. So I don't know if you can see my faint table, but these are my subjects, 1, 2, 3, 4, 5, 6. And I have my numbers before and after. What I need to find is how did they change over time? You always take the first sample minus the second sample. So whatever you call the first sample, just keep it all the same. In this case, 210 minus 190 is a positive number. That means that before it was higher and now it's lower. For my second problem, or for my second subject, I have 235 minus 170. I have a 65. So for the first subject, it went down 20 units. For the second subject, it went down 65 units. 108 minus 110 is a negative number. So this means that for subject number 3, it actually went up. So 190 minus 188, that's a positive 2. This is again negative 1. And 144 minus 228 is positive 16. So this is my differences. This is how it changed. If most of them are somewhere around negative 2 or positive 2 or negative 1, it would probably suggest that there is no big change according, if you take the supplement or not. But with those 20 and the 65 and the 16, it does mean that the after kind of it lowered whatever we're studying, in this case cholesterol level. So this is what I want to analyze, and this is the differences that I'm interested in, because my subjects could vary a lot, meaning one person could be really healthy, one, I don't know, really low cholesterol, like 150, 170. I could have somebody with much higher, like 230, 250, maybe 300. I don't even know what the numbers are for cholesterol. But you don't want to take an average of people because people vary. What we want to take is the average of the differences. So this is why we're interested in one sample only, and this is what we get to enter in our L1. So go into stats and edit first. Your L1 should consist of 20, 65, negative 2, 2, negative 1, and 16. If you'd like to follow me with this example, pause, take out your calculator, and continue. 20, 65, negative 2, 2, negative 1, and 16 goes into your L1. You're going to quit this menu, go back into stat, go over to tests, and what you're running is you're running a t-test. It is taken from data, and all it's asking is your hypothesized mean. The hypothesized mean is that mu sub d, which we assume must be 0. So this is how you start pretty much every problem in this section. So you let it equal to a 0. For this particular example, it is a two-tailed test, so I'll choose the not equal to sign, and the rest is calculations. The t-test statistic came out to be 1.61. The p-value was calculated at 0.16 0.87, so I'll round this up to a 9, and it is definitely greater than 0.1, which is given to me at an alpha, as the alpha level back in the problem. And this suggests that we do not reject the null hypothesis. If you take a look back at your data, you'll notice that for 3 people, it did make a difference. The other 3 people didn't really. In particular, 2 people that actually went up. So the supplement, according to the sample, doesn't look like it reflected into lowering the cholesterol or changing the cholesterol. You see, we're using the word change, so this is what you might put into your final sentence. Can it be concluded that the cholesterol level has been changed in using the supplement? Not enough evidence to suggest that the mineral supplement has a change or changes, let's keep it this way, has a change on cholesterol level.